Great, so that's perfect. So we're going to talk today about graphing using a T-chart. Graphing, so get out your notes if you don't have them, using a T-chart. So whenever I write something on the board,
we should write it.
You should write it in your notes, because that's what the teacher thinks is important, and I guarantee it will be on any test you take. You know what I mean? I would not waste my time or your time to put something on the board that I don't think is important. Oliver, would you do me a favor and close that door? I don't know where that's coming from, that noise. But...
The other room.
All right, so I'm going to just start with these three that are on the homework, okay? And I think you're going to start to see how they're actually quite quick. You can do these. The homework to this weekend, you'll be able to go through these quite quickly. Okay? So here we go. We've got the first one, number 1. It says graph. Using a T-chart, y is equal to 2x plus 3. It's amazing how loud that is. Okay. So here's my graph. But before I can actually do anything, I actually have to do a T-chart. And all the thing, understand. So Cassius, I'm gonna back up just a second and show you guys something. Are they outside? That's why. I don't know why it's so noisy. Are they right by that door?
Yeah.
Is that what's going on? Okay. Whatever. Yeah, maybe.
Shut
Could
up.
you just tell them to just be a little quiet, or maybe find
For the
another
video.
spot.
Can you be a little bit more quiet? Can you be a little bit more quiet?
Okay, so I want to show you guys something. Okay, everybody look up here. Everybody look. When I do this, x plus 4 equals 10. How many variables? 1, right?
Yeah.
Can I solve it? Can I figure out what x is?
Yes.
Right? How many equations? Just one equation, one variable. If I have one variable, all I need is one equation and I can solve it. Easy. I subtract 4, x is equal to 6, right? I know that. There's only one option. There's only one right answer to this, x equals 6. As soon as I move to two variables, I've got a y and an x, but I only have one equation. There's actually no one right answer.
Oh, I get it now.
X and y, if I knew what x was, I could figure out what y was. But since I don't, I have to figure out all the possibilities of x and then all the possibilities of y. And they're an infinite number. If x were 1, 2 times 1 is 2, plus 3, 5, right? If x were 1, y would be 5. But if x were a million, 2 times a million is 2 million and 3. Y would be 2 million and 3. Do you see what I'm saying? X could be anything. I don't know what it is. So because of that, I'm actually going to have a line that shows all the possibilities of x and y. That's what a graph is. It's showing all the possibilities. If x is this, y is this. 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 Do you follow me? Do you see what I'm saying? And so it's going to be a straight line. So what I have to do is I create a T-chart. I could do 1,000 possibilities, but I don't want to do that. It's going to take me forever. So all I do is I choose three numbers. Here's my x, here's my y, and I choose 3 easy numbers. And don't you agree with 0, 1, and 2 is pretty easy?
Yeah.
You could start with 1, 2, and 3, but 0 is the easiest one on the planet, right? So I would prefer starting with 0, and 1, and 2. And so now all I do is I say, if x is 0, what would y equal? Y equals 2 times 0. What's 2 times 0?
0.
0. 0 plus 3 is 3. So I would just put y is 3 when x is 0. It's not 3 when x is 1. It's only 3 when x is 0. Now, what is y when x is 1?
2.
2 times 2 is, 2 times 1
2.
is 2.
And then 4.
It'd be 5.
Plus 3 more.
Oh, okay.
Right? 2 times 1 is 2. Plus 3 more is 5. So that would be 5. Now let's try 2. 2 times 2 is 4,
Four.
plus 3,
7.
it would be 7. All right,
That makes more sense.
does that make sense to you?
Yeah.
T charts are
No?
Easier. Yes, I don't know.
interesting.
So all I'm doing is I'm substituting this 0 in for x.
Oh.
So I'm doing this. In essence, I'm doing it in my head, but this is what I'm doing. I'm writing y is equal to 2 times 0 plus 3. That now I don't have an x, I have a 0 in place of x. 2 times 0 is 0. So y is equal to 0 plus 3, which is just 3. Boom. Right?
Boom.
For this one, I did y is equal to 2 times 1. Instead of x, I'm putting a 1 in there. Does that make sense, Una, now? Plus 3. So 2 times 1 is 2, plus 3 more, 2, 3, 4, 5. 5. That's all I'm doing. I'm just redoing this, but I'm substituting this number in here. Does it make sense? Okay, so these now, all I need is 3 points, and these are 3 points. These are the same things as if I wrote them parentheses 0, comma 3, parentheses 1, comma 5. But I don't bother doing that because they're already written here, right? With my left on the, my x's on the left and my y's on the right. So now I just plot it. Okay, so it says 0, comma 3. 0, I go nowhere to the right or left towards x. I stay where I am. But 3, I go up. So I go 1, 2, 3, and I put a dot right there. My next one is 1, 5. I go over 1, start at 0, go over 1, go up 5, right there, put a dot. And then 2, 7. I go over 2, I go over 2, and I go up 7, put a dot. And it better be a straight line. Is it a straight line?
Yes.
Now, then I draw a line. Now notice, has anybody noticed that I chose 3 points? When really, how many points do I need to draw a straight line? 2, right? Wouldn't have been, it would be so easy to just do 2. But why do I choose 3?
Shows the line more.
It does show the line more, it makes it easier to draw it, right? Accurately. But there's another reason. What if I did 3 points and instead of this point here, I had a point here? What would I know?
To know if it's correct or not.
I would know that something's wrong. I don't know whether the line is this, I don't know if it's this, or if it's that. You know what I mean? Something I did wrong. So I go back to the drawing board and get it so that it gives me a straight line. Find the one that I did wrong. Does that make sense?
Yeah.
It's sort of your proof. It's your way of making sure you do it right by doing 3 dots. Because if they're all in a straight line, you pretty much likely did it right.
There, you should
If,
do the shortcut now.
we're not going to do the shortcut
I
yet.
know, but just to show.
The shortcut is unbelievably fast, but we're not going to do that quite yet because you really have to know this. Okay, so that's the first one. Now let's do the second one.
You could do the shortcut if you want to see if it's correct, right?
On the home, yeah, you could. Okay, I could have done that. Maybe I should have done it, but yes.
Are you video? Are you doing
Yeah,
this?
he
on
is.
video?
This is on the video, on the camera. And then, okay, number 2. I'm running out of time, as usual. But number 2, here we go. We've got
5
y is equal to 2x minus 5. Now here's my graph. This is my x-axis. This is my y-axis. Okay, I'm going to do my t-chart. Again, this always works. Oliver, you taking notes, buddy?
Yep.
You sure? Okay. What am I going to put in my x? 0, 1, and 2. Almost always I start with those. But I'm going to show you when I don't in just a second.
Wait, if it asks for like 5, then do we have to go like from 0 to 4? In word
Yeah,
problems.
yeah. They probably wouldn't, but if they did, yes, you would. So, all right, so if x is 0, I go to this equation, and I'm just going to fill it in. Just like, so I'll do it the long way. Y is equal to 2 times 0 minus 5. 2 times 0 is 0. What's 0 minus 5? Negative 5, right?
Yeah.
Okay? If y, now I'm going to do it in my head. I'm going to replace it. Y is equal to 2 times 1. 2 times 1 is 2 minus 5. Negative 3. Now I'm going to do this in my head. 2 times 2 is 4. Minus 5 is negative 1. Are you guys all starting to see this now? Does it make more sense? So now I'm going to go over here. 0, negative 5. Boom. 1, negative 3. Boom. 2, negative 1. Boom. Are they in a straight line? Pretty close. You know, it's slightly off just because I'm not graphing on real graph paper. But that's pretty good. Okay, and the goal is to get the line to go through the dots, not next to them. But you got the idea, right? Pretty easy, right? So because I'm running out of time, I'm going to skip the third one. Okay, and I'm going to go right into another thing that I wanted to sort of show you. What if I gave you something like this? I don't know if I have enough time to do this. Ugh. Okay, so this is in your notes now. So this is number 3 for your notes. What if I gave you y is equal to 1/2 x plus, I don't want to give you the one on the homework, hang on. Plus 2. When it's something like a half, it's actually not so hard. I could just do the 0, 1, and 2. But let me show you what would happen if I did 0, 1, 2. I have y is equal to 1/2 times 0 plus 2. 1/2 times 0 is what?
0.
0 plus 2 is 2. That's easy, right? That worked great. But now let's look at the next one. Y is equal to 1/2 times 1 plus 2. What do I get? What's 1/2 times 1? 1/2, right? What's 1/2 plus 2? 2.5. So that's not too bad. I could do that. I can plot 2.5 pretty easily, right? I just go halfway between two corners, right? And then this one, interestingly, look at this, 2, and notice that the denominator is a 2, right? Let's see what happens when you have a multiple of 2, or 2. Okay, so 1/2 times 2 plus 2. What are 2 halves? Right, the 2's cross out, right? Because it's 2 over 1. So it's just 1. So it's 1 plus 2, which is 3. Does that make sense? Now notice, this one was really easy. It gave me a nice, solid whole number. Do you see this, Luca?
Yeah.
The 0 gave me a whole number. The 2 gave me a whole number. The 1 did not. If I remember what we said what multiples are, multiples of 2, 2 times 1 is 2, 2 times 2.
Right.
2 times 2 is 4.
2 times 2 is 4, Gary. Learn it.
Multiples of 2. Multiples of 2. Poles of 2. Right? So 2, 4, 6, 8, 10, 12. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, 2 times 6 is 12, whatever, right? If I used any of these multiples, are you guys listening? If I used any of these multiples in here, I will always get a whole number.
But eventually we won't be able to put them onto the graph because it'll be too big, right?
Well, yeah, you would probably, I would choose, if it were me, I would choose 0, 2, and what's the next one?
3,
4. I would do 0, 2, and 4 if it were me, because then I would have whole numbers, right?
Right.
You guys with me, or am I losing you? I'm losing you?
No.
No, you get it?
But it's
See what I mean?
time
Can
for
you
lunch.
use 4? Can you use
So
4?
yeah, so watch. Y is equal to 1/2 times 4 over 1, right? Plus 2. Look what happens. 2 goes into 2 once. 2 goes into 4 twice. I have a 2 here. y is equal to 2 plus 2 is 4. Cool.
Wait, so how did I don't get it. So, 2, and then, oh, alright.
I cross reduced. But if I didn't, I could just do it like this. I could do 2 over 1 times 1 over 2, sorry. 1 over 2 times 4 over 1. That would be 4 halves, right? 4 halves is 4 divided by 2, it's 2. Right? So 2 plus 2 is 4.
No, wouldn't
So-
it be 5 because you still have that 1 on top?
No,
The
because it's 1/2 times 4. So when I
Oh, yeah.
simplify, 2 goes into 1, 2 goes into 4
Okay.
twice. 2 times 1 is 2. Over 1 times 1 is 1. 2 over 1 is 2. So 2 plus 2 is 4. You with me? So if I gave you, it's not so hard with the half, the very first one on the homework. You could probably get away with doing 0, 1, and 2. But with some of the others, like the last one, I think I did 1/7. Right? So if I did that, let me just give you an idea of what I would do. Let's say I said 1/7 x plus 2. I would do multiples of 7. 7 times 1 is
7. 7 times 7.
7 times 2 is,
14.
I would do those two. I would do 0, 7, and 14. Does that make sense? So I would go 0, 7, and 14, and that's for your last problem on your homework. That's what I would do. Does that make sense?
Yeah.
Multiple, do you get it? Multiples of the denominator. 7 plus 7 is 14, so 7 and 14, and I would always use a 0. 0, 7, 14. And you'll find they come out evenly and nicely. That's what I would do, okay? All right, that's it. I have the homework for you. Don't leave until I give it to
Are you
you.
done with